In the early days of programming, software was dedicated to solving narrow specialized tasks and required deep expertise to build. As software evolved, it became suitable for solving a wider range of tasks for a larger audience of users. Programming itself has also become significantly easier and more accessible. This growth skyrocketed with the rise of the internet and mobile devices, but has begun slowing in recent years. AI opens the door to sustained exponential growth, and Atom54 unlocks unique opportunities to accelerate development and solve an even wider variety of problems. Over the years, programming evolved from punch cards to assembly and then to higher-level programming languages that are more developer-friendly. However, between programming languages and the software end product, there is still the uncharted territory of unstructured software. Within this layer, developers have to keep solving the same problem over and over, each reinventing the wheel. This causes incompatibility and less efficient solutions, as well as extra manual labor. Recently, more frameworks, libraries, and developer tools are being introduced in this intermediate layer. They each address certain problems, but they also introduce new challenges. First of all, dependencies, which make software vulnerable to breakages, downtimes, and licensing changes. Next, compatibility. Different frameworks and libraries may not work well together smoothly, requiring time and effort to reconcile. Next, cumulative costs of frameworks and underlying resources may be a constraint, especially for individuals and smaller businesses. Next, lack of flexibility and customization, as standard libraries and frameworks often aren't precisely suitable for the problem at hand, which may result in a compromise in the end product's functionality. And finally, lock-in. After a dependency on a service or library is introduced, it is difficult to revisit and switch to an alternative provider, especially once the software is already in production. Atom54 introduces a new layer in the software technology structure. This layer consists of A, the Xenon core framework, which runs the atomic components, B, an ecosystem of atomic components, and C, an environment for morphing, evolving, and growing components. It is important to note that Atom54 is not a monolithic layer. It is in fact quite the opposite. The atomic components are independent of each other and also, most importantly, independent of the framework. Similarly to how biological cells get connected together to form tissue, organs, and organisms, the atomic components get connected to form features, experiences, and applications. The Atom54 framework and the ecosystem of components introduce novel concepts and unique properties to programming, addressing the status quo challenges described above. Over the course of its history, programming evolves from linear programming, typing commands, to block programming, visual programming environments. We introduce the next generation of programming, atomic programming. To use an abstract analogy, imagine switching from today's mechanical prosthetic arm that is made of plastic, titanium, silicone, etc., to a prosthetic arm that is grown from human cells and tissue. The biological arm has a significantly better sensitivity, feedback, and movement support than the mechanical one. Similar is the qualitative leap from linear or block programming to atomic programming. Each atomic component is like a biological cell that responds to stimuli. The larger compounds of atomic components have more complex reactions and motivations, and constitute software that evolves and morphs depending on the built-in goals and requirements, and the context that it operates in. Let's dive into how atomic programming actually works. Within the software, we have a basic code unit called the atom. Every atom is defined by its inputs and outputs. Atoms are reactive, and they only do work if one of their inputs changes. Atoms can be composed into components by connecting their inputs and outputs. The atomic components are modular and have no interdependencies. The data is decoupled from business logic, decoupled from UX, and so on. This allows any module to be modified or replaced without affecting the stability of the rest of the system. It's like replacing a tire or an engine while you drive. In this paradigm, developers have the freedom to control every choice of underlying technology or service provider, or alternatively, fall back on the framework's deliberation for decisions they don't want to make. Every component is easily pluggable. For example, the developer may specifically choose file-based storage and later replace it with a fission storage. On the other hand, the developer may just request an abstract persistent storage and let the framework choose one. Moreover, each component can stand on its own, and developers have the freedom to run their components independently outside the Atom54 framework. The modularity and dependency-free architecture allows the atomic software to run on any device or combination of devices on any platform or OS. Like any other implementation aspect, the UX is pluggable and optional. Atom54 experiences can include no UX whatsoever and run as background server tasks. The decoupling of UX also allows Atom54 to render UX onto any rendering surfaces, for example DOM, or multiple surfaces and devices. The framework manages the cross-device orchestration of components while being transparent for the developer. Atomic programming leverages AI on all levels, starting from an individual atom that can use AI to perform the standard regression, clustering, classification, and other operations. AI can be used to co-author the code of an atom. Atoms are usually relatively small and well-scoped code units, well suitable to be generated by an LLM. Atoms can also use AI for interaction with reality interfaces such as vision, sound, speech, touch, motion, and more. One of the areas of technology with huge potential and under-delivered promise is the wearable, AR, VR, and IoT spaces. All these involve multi-device scenarios and much closer interaction with physical reality than the classical use cases addressed by software. These areas didn't get enough developer community engagement simply because it is hard to develop for these devices. This is where Atom54 can make a big difference. Not only does it facilitate multi-device experiences, it does so in a general-purpose, device-agnostic way. A composition of atoms can be treated as a logical atomic unit of itself. It is similarly defined by its inputs and outputs. And in the same way as the basic atom, the composition of atoms themselves are composable by connecting inputs and outputs. Due to its composable nature, the atomic software is future-ready and adaptable to innovations yet to come. Last but not least, composition is always semantic, as it is defined by connecting inputs and outputs of the components. The LLMs are well positioned to reason about the composition and create novel experiences. The more users rely on software in their daily lives, the more they compromise their privacy. Users are forced to repeatedly share their personal data with applications and services. They are forced to choose between leveraging new, exciting features and their privacy. User data is required for the software, especially a modern AI-powered one, to provide good services. Data is not only problematic for the users to give out, but also costly for developers to gather, manage, and protect. This becomes a significant barrier to software adoption. Atom54 solves privacy by implementing the code comes to data paradigm. The user retains full ownership of their data. Atomic software is defined by the data flow, and the data flow can be analyzed and privacy policy rules can be enforced. The access to data and the data flow are governed by the framework. Data privacy is built into the very core of the system. Privacy guarantees are only as good as the security is. Atoms or compounds of atoms can be executed in isolation from each other. The levels of security can be adjusted and made suitable for sensitive data as needed, for example, to handle financial or medical information. With Atom54 software, users maintain full sovereignty and ownership of their data. With Atom54, there is no more need to share personal information with third parties, and no more losing data when switching between applications or service providers. Atom54 software provides built-in privacy guarantees and adjustable security levels. To summarize, Atom54-based software introduces a wide range of unique properties and capabilities for users and developers' benefit. Firstly, Atom54 software is made out of composable components that can be universally applied to any use case and any scope of tasks. This spans from extending an existing product, to prototyping a quick experiment, to building a full-scale production-ready app from scratch. Next, solutions can be fully composable from off-the-shelf components, implemented by specifically tailored custom components only, or built in as hybrid solutions that extend off-the-shelf components with custom software. An ongoing growth of our ecosystem of components triggers the flywheel effect and unlocks an exponential growth of functionality supported by off-the-shelf, while developers retain full flexibility to customize, adjust, and evolve the product. Atom54 enables developers with any skill level and background to build products and solutions. Our visual programming, no-code environment removes the entry barrier for developers and facilitates a significant democratization in software development. Low-code programming or full-stack development environments are also available, which makes software development flexible and robust. One of the major differentiators of our technology is that Atom54 is truly an open framework. All of our demos are available live. You can customize them or build your own and immediately start using or sharing them. Our IDE is available on the web, no registration, build, or depository steps required. The smooth, accessible software composition process is part of the DNA of our framework. Links to the demos, our website, and repository are available below this video. Please check them out and start creating your own experiences. Thank you.